I got this heater a few months ago. It's relatively new, and it had worked great here in the shop because it was quite powerful and it was very quiet. I turned it on about 2 or 3 minutes ago, and of all times, as I was formatting the memory card, it made a smoke releasing sound, and then some magic smoke started pouring out the output of the machine. And I think the fan stopped. The light was still on, and then I unplugged it. Now the element doesn't look like it's shorted out or anything, so potentially it could be repaired. I don't know. Let's see if we can figure out what the problem is with this. I'm not really sure what happened. There's some evidence there that this got very hot at some point. Come on, unblur. That looks like it could have gotten pretty hot at some point. And then that looks like it got very hot at some point as well. So, I don't know. What I don't understand is that this wasn't running for very long when it quit. There's times that this thing runs 5, 6, 7 hours at a time. Today, it was on for just a matter of moments before it quit. So, I find it odd that it quit today. It's not impossible that perhaps this connection, for whatever reason, was heating up over time, and today was its breaking point where the insulation or the connection became distanced and there was an arc or something like that. I'm not entirely sure, but we're going to have to remove some of the wiring in order to figure it out. Okay, so we're inside the machine now, and I have disconnected some of the wiring so we can have a closer analysis of the situation here. Now let's start with the resistance readings. Okay, we're going to measure the fan, see if the fan is okay, and the fan is reading 87, which is a reasonable rating for a motor. Now the element, if you were to calculate the theoretical resistance via Ohm's law, in this case because it is a 1500 watt element on a 120 volt circuit, the resistance would be approximately 9.5. Now we're probably going to get a much higher reading than that because these elements have a positive temperature coefficient, which means that when they're hot, the resistance will go down. And since this is not hot, it's at room temperature, we are seeing a higher reading, which is kind of fluctuating a bit here. We're not getting a very good connection in the terminal. We're getting about 20. I don't think there's anything wrong with this heater at all. I think there's, I don't know, something was wrong with that connection. Either it wasn't crimped hard enough or in the right place. But you can see what transpired is this just completely melted. It's just burnt to a crisp. This is a very drastic failure here. And you can see on here where it spewed some of the smoke or whatever it was that came out of there. So that's the problem. Now, when I rewired this, I tried to do it the right way. You could put a trillion quotes around the word right in that sentence. And so I used these terminals, and I don't know, perhaps they were, I don't even think it was a function of being underrated, because it looks like the problem transpired at the joining of the wires, not even where the terminal is. So anyways, for whatever reason this failed. So now what I'm going to do is I'm going to redo it the so-called wrong way, and I'm going to, instead of using this terminal, I'm going to make the loop out of the wiring, I'm just going to put the wiring right on there. It's probably going to work for another 20 years and there'll be no more problems. So, let's see what we can do here. Cut this off. Now, of course, there is the potential that something transpired to cause this situation, because more likely than not, well, I shouldn't say more likely than not, I guess there could have been an issue here, but I do have a slight hunch that something transpired to cause an additional power draw, which caused this to happen. Now we're out of wire, so I'm going to have to get a longer piece of wire in order to be able to get that on there. I've got some 14-4 wire here, and we're going to use this to make our connection. Where did it go? Here it is. And actually this kind of works out better because it's easier to make a good hook and get a solid connection out of a solid wire than stranded. So I'm going to strip this ahead of time so it's a little bit easier to do. And that'll go right onto the terminal. Need another wire connector. Okay, so this goes on here like this, and this will go on here, now, whoops, was there a, no, there isn't, okay, I think what I'm going to do is I'll put that on first, and then this. Is that a good idea? No, it's not. I'll do it like this. Okay, it's a good solid connection there. Oh, this has to go on there as well. Actually, you know what I could do? It does not have to go on there, it can go in here. It's a little burnt at the end still, we gotta strip back further. This is totally not essential. It's just an indicator light, but might as well make it work again. Okay, I'm going to join these two together. Okay, these are all sturdy in there. Now we'll put the fan back on with the washer, or the nut rather. Okay, now let's check the overall resistance reading here. Yeah, it's 9.3, so actually it's almost exactly where it should be. So I think that this is going to run again and work just fine. I gotta kind of bend this back up here. Since I really do expect it to work again, I gave the fan some oil. Bearings are working very well now. Okay, here we go. Going to plug it up now and see what happens. It's heating. Before I run it any longer, I want to throw it on the kilowatt meter and see what the draw is, so that we can have an idea of just how normally it's operating. Okay, we're testing at 130 volts, 122 volts. I think this kilowatt meter doesn't work very well anymore. Switch it over to watts and plug it up. $14.61 watts. 1470 watts. This is a 1500 watt heater, so we're right about what we should be. Alright, well, I am confident in that. It's getting hot. It's moving air. Now it's been sitting for a few minutes and it seems to be working just fine. I think I'm going to leave it on the kilowatt meter for a while just to make sure the power draw isn't going up. Right now it's going down, which makes sense. So I'm going to put this back where it was, and with it wired the wrong way, it'll probably keep working for many more years. This has been running for the whole night, and it's got a reasonable power draw to it. I don't know if it's actually fluctuating that much or if this kilowatt meter is kind of flaky. But it seems to be working fine, so I think that is going to be okay at this point.